Note that the general term of the given series, let's denote it by UR, can be expressed as 2 raised to the power R minus 1 multiplied by R divided by R plus 1 times R plus 2. Now multiply the numerator with the expression R plus 2 minus R plus 1, the value of which is equal to 1. Therefore, UR can be expressed as the difference of two terms. The first term is 2 raised by R minus 1 times R plus 2 divided by R plus 1 times R plus 2. And the second term is 2 raised to the power R minus 1 times R plus 1 divided by R plus 1 times R plus 2. R plus 2 cancels across the numerator and denominator in the first term, and R plus 1 cancels in the second term. Therefore, UR is equal to 2 raised by R minus 1 times R divided by R plus 1 minus 2 raised by R minus 1 times R upon R plus 2. Add and subtract 1 in the numerator of the first term, and add and subtract 2 in the numerator of the second term. Therefore, UR can be written as 2 raised by R minus 1 times in brackets R plus 1 upon R plus 1 minus 1 upon R plus 1 minus 2 raised by R minus 1 multiplied by in brackets R plus 2 upon R plus 2 minus 2 upon R plus 2. This can be written as 2 raised by R minus 1 multiplied by, in brackets, 1 minus 1 upon R plus 1 minus 2 raised by R minus 1 times, in brackets, 1 minus 2 upon R plus 2. Taking 2 raised by R minus 1 common, we get 2 raised by R minus 1 multiplied by, in brackets, 1 minus 1 upon R plus 1 minus 1 plus 2 upon R plus 2. 1 cancels inside the brackets, and we are left with 2 raised by R minus 1 times 2 upon R plus 2 minus 2 raised by R minus 1 times 1 upon R plus 1. Therefore, the general term of the series UR is equal to 2 raised by R upon R plus 2 minus 2 raised by R minus 1 upon R plus 1. Let's denote the first term by VR. Notice that the second term is the same as VR with R replaced by R minus 1 is therefore equal to VR minus 1. Therefore, UR can be expressed as VR minus 1. Therefore, the sum of the given series to n terms, let's denote it by Sn, is equal to U1 plus U2 plus U3 plus and so on, plus Un minus 1 plus Un. Using the result obtained above, U2 is equal to V2 minus V1, U3 is equal to V3 minus V2, and so on till Un minus 1, which is equal to Vn minus 1 minus Vn minus 2, and finally Un is equal to Vn minus 1. Therefore, Sn can be expressed as U1 plus V2 minus V1 plus V3 minus V2 plus V4 minus V3 and so on, plus Vn minus 1 minus Vn minus 2 plus Vn minus 1. Notice that V2 cancels with the V2 in the next row, V3 cancels with V3 in the next row, and so on and so forth, till we are left with only 3 terms on the right hand side. And therefore the right hand side is equal to U1 minus V1 plus Vn. Recall that UR is equal to 2 raised by R minus 1 times R upon R plus 1 times R plus 2. Put R is equal to 1, we get U1 is equal to 2 raised to the power 0 times 1 upon 2 times 3, which is equal to 1 upon 6. Also recall that VR is equal to 2 raised power R divided by R plus 2. Put R is equal to 1, we get V1 is equal to 2 upon 3. Substituting these values in the above expression for Sn, we get Sn is equal to 1 upon 6 minus 2 upon 3 plus Vn, which is equal to 2 raised power n upon n plus 2. And this is equal to 2 raised power n upon n plus 2 plus 1 upon 6 times, in brackets, 1 minus 4. And therefore, the sum of the given series to n terms is equal to 2 raised power n upon n plus 2 minus half, which is the required answer.